In today's lesson, I'm going to discuss variation. We're going to talk about how one variable is related to another variable, or even perhaps two other variables. The concept of variation leads directly into the concept of functions. If two variables vary together, then one is a function of the other. We will talk about direct variation, inverse variation, and joint variation. I will also give you a definite procedure to solve any variation problem. Let's look at an example. Pinto beans are priced at 89 cents per can. As one buys more cans of beans, one must pay more money. In other words, the amount one must pay is directly related or directly proportional to the number of cans bought. For this particular problem, the total cost then is equal to 89 cents times the number of cans, because the pinto beans are priced at 89 cents per can. So the total cost is directly proportional to the number of cans that you buy. In this case, the 89 cents is called the constant of proportionality. Now, for this particular size can of pinto beans, the 89 cents is constant. So for every can of this size and this brand that you pick up, you will pay 89 cents for it. Now, if you decide to buy a larger can of pinto beans, then it will no longer be 89 cents. Or if you decide to buy sauerkraut rather than pinto beans, it will probably not be 89 cents. But for this brand of pinto beans in this size can, 89 cents is constant. It's called the constant of proportionality. So let's look at the direct variation model. In words, we say that y is directly related to x, or y varies directly as x varies. So in words, we would say y is directly related to x. We could also say y is directly proportional to x, or we could say y varies directly as x. All of those things imply a direct variation model. In symbols, we write the direct variation model as y is equal to k times x, where k is the constant of proportionality. So for the particular problem you're dealing with the size, can, and the brand of beans, the k would remain constant. Let's look at another type of variation. The distance between two exits on an interstate highway is 20 miles. Now, I picked an interstate highway because you can probably maintain a constant speed. So on an interstate highway, we'll assume that you can just set your cruise control on whatever speed you want to travel, and you can travel that constant speed for the full 20 miles. Now, on this interstate highway, as one drives faster, the time required to reach the second exit decreases. So as you drive faster, time decreases. So think about it. You have a fixed 20 miles to cover. The faster you drive, the quicker you're going to get there. In other words, time is inversely proportional to speed. Speed increases, time decreases. So that's what we mean by inversely. As one increases, the other one decreases. Now in direct variation, like with the beans, as the number of cans increased, the cost increased. So both of them went in the same direction. But in inverse variation, as one increases, the other one decreases. For this particular problem, time is equal to 20 miles divided by the miles per hour. And that would give you the time in hours. So time would equal the fixed distance, 20, divided by the speed that you travel. You might recall from earlier studies that distance is rate times time. So then, for fixed distance and solving for time, I can get, or divide both sides by r, I get that time is distance divided by rate. In this case, we've got the fixed distance. The speed or the rate is what's varying along with time. So this is where the formula came from. But I didn't need to know this to set the problem up, because we did talk about that it was inversely proportional. I'm just trying to relate everything that you know so that you can apply it easier. For this problem, 20 is the constant of proportionality, because what remains constant in this problem? And that would be the distance between the two exits on the interstate. That you can't change. Let's look at the inverse variation model. In the inverse variation model, the words would be that y is inversely proportional to x, or we could say y varies inversely as x. So there would be two ways of writing it in words. Y is inversely proportional to x, or we could say y is inversely related to x. So we could use related to rather than proportional. It means the same. Or we could say y varies inversely as x. The key word is inversely. Now in symbols, if you have the inverse relationship, it's going to be y is equal to k divided by x. My printer got a little bit out of whack here and I didn't catch it in time. So it would be y is equal to k over x. In other words, you divide by the variable x. K is still your constant of proportionality. So here's the model for inverse variation.